Good afternoon, everybody. This is student meteorologist Eric Drewitz with Weather International, also forecasting internet AccuWeather. Currently across the central Pennsylvania region, we have temperatures in the middle to upper 70s to lower 80s. Temperatures get a little cooler farther north and west you go towards the Great Lakes, with temperatures in the middle to upper 60s to lower 70s. And then farther south and east you go, temperatures are warmer with the middle and upper 80s. Dew points right now are relatively high, causing for very humid air across our region, with dew points in the middle to upper 60s. And now changing gears here, let's look at the 500 millibar winds and sea level pressure on the Earth wind map. This is the current GFS analysis at 18Z today, or 2 p.m. So this was the initial analysis then, and looks like we have a little bit of trough of lower pressure moving into our region, and then you see also Blanca off the coast of Baja California down there. Changing gears here now, going to looking at the surface temperatures and winds. We have looks like relatively a cooler air mass over here in Ontario and Quebec provinces of Canada, north of the Great Lakes region, and going into the 850 millibar level that you see the thermal advection, it looks like we will have neutral to slightly cold air advection. So that makes sense, considering right now we're actually kind of along a boundary of cooler air and warmer air. So anyway, going into the current watches and warnings by the National Weather Service, because there's actually quite a bunch. We have tornado watches actually all through up central Pennsylvania, almost Center County, and eastward. We even have tornado warnings across these areas in red, severe thunderstorm warnings across these areas in orange, and then other statements that are overlaid underneath. So, excuse me. Here's the current enhanced water vapor satellite imagery, showing a boundary of to our west and our east. It looks like winds west of this plume of moisture are coming out of the northwest from Canada, so cooler and drier air to the west of this, typical with a air mass that originates in Canada, which is continental polar usually. And to our east, it looks like we have, air coming from up from the Gulf, which makes sense considering there's this outbreak of severe weather. So, getting into the fun stuff, current radar imagery shows a line of strong and severe thunderstorms crossing through central Pennsylvania, another line back here through Indiana, Ohio, isolated showers and storms up here in the Great Lakes of Michigan and Wisconsin and Illinois by the Chicago area. And all these areas in these yellow boxes are severe thunderstorm warnings. This green box here is flash flood warning, and these red boxes, which is the fun stuff, are tornado warnings. So now actually changing gears here a bit, going into the SPC meso analysis. First, let's see. SPC has a marginal look for most of our region, but a slight risk for the region, our region, and a little bit eastward, with warnings and MDs issued, but I won't go reading the MDs because that's their forecast. Anyway, now going into the meso analysis, let's go over here since I'm in State College, Pennsylvania this summer. Actually, let's go a little bit more northeast if I can. All right, this one's better. So looking at the different weather parameters, let me zoom out a little bit to just my screen here. So let's look at Cape first, because that's the easiest one to look at. So currently we have about 1 to 2,000 joules per kilogram of Cape, about 1,500. So that's definitely enough that can initiate thunderstorms and severe weather. Not much SIN, very negligible SIN, which is good because SIN prevents parcels from reaching their LFCs and ascending upward. So SIN is not good for thunderstorm development, but Cape is, for all you non-meteorology majors out there. Now, going into the wind shear, let's look at the bulk shear first. So the 0 to 6 kilometer wind shear, and it looks like right now we have at least 30 knot bulk shear, 30 to 40 knot bulk shear across central Pennsylvania, which is very good for severe weather development. And let's look at a helicity, because since there were tornado warnings and watches issued, for helicity you want between the 0 and 1 kilometers, you want about 100 meters squared per second squared of that. So looking out ahead, Looks like, yeah, we have areas of 100 plus 0 to 1 relative velocity, so that looks good for tornado development. Actually, going back to Cape, let's just look at what it looks like a few hours ahead. Yeah, definitely significant Cape with very little sin until we approach 2Z, 0 to 2Z tonight. So definitely thunderstorms are likely in the earlier part of our evening. And let's quickly look at the bulk shear again. Very good bulk shear around 22Z or 6 p.m. Eastern Daylight Time. And now, yeah, very, very good bulk shear around our area. Bulk shear in excess of, 30 to 40 knots. So that's very good for severe weather development. Let's see, currently moisture convergence. Wow, we have mixing ratios. It looks like over 10 grams per kilogram for the northeastern U.S. Even this pocket of 16 right here. So very, very moist air for the region compared to normal, with also some good moisture convergence, and that's good because that allows for deep moist convection aloft, and it really is good for thunderstorm development. Look quick at the supercell composite indices. Yeah, looks like we have indices between 1 and 2. So definitely better than most times for the northeastern United States with severe weather. Because growing up on Long Island and also being a student at SUNY Oswego, I rarely get to see severe weather that much. I guess looking at surface observations again, we'll see, because this one we can see a little bit more west. I don't really see much of a dry line, although I will talk about lift later because I'm going to give shout outs to AccuWeather, because there's a lot of new forecast methodologies that I'm going to be using in this video that I have not used previously, that I've learned throughout the course of the few weeks I've been at the internship so far. So now going into basic stuff, 1,000 to 500 millibar thickness and sea level pressure and QPF, and you can see this is 0Z or 8 p.m. tonight. You can see definitely a cold boundary, a cold front across the northeastern United States. This is the NAM, GFS, European, and Canadian. Canadian, the latest model is out is 0Z, but all the other ones are 12Z runs. And as you see, as all of us meteorology majors know, whether if we learn QG theory or not yet, heights fall ahead of a trough, and troughs are usually cooler air, always cooler air. So as you see, there's a cold front that's going to be passing through our region, and let's go forward ahead to 0Z tomorrow again with the GFS right here, and you can see the heights falling and the precipitation moving east and out of our region. So anyway, now moving gears to actually, this is the 850 millibar heights, relative humidities, and winds. I don't know why these ones loaded weird, but I will quickly reload them for everybody to see. Sometimes it does that. I apologize. And we will move from here, I guess. We'll just work with what we got. So anyway, this is the 12Z one of the NAM. I'll show this first because it's the one that's open. And I see a lot of moisture at the 850 millibar level, which is also very good for precipitation clouds. Not much in the way of dry air intrusion aloft for most of the time period between now and Friday. It looks like a little bit of dry air intrusion according to the NAM around 60 Thursday, but it looks relatively moist. I'll wait for these to load, and I'll talk about other things in the time being. So anyway, 700 millibar. Now let's look at the 700 millibar level with moisture is concerned, so the relative humidity. So this is what it is at 0Z tonight. Lots of moisture. The NAM shows a little bit drier at 700, and then the GFS also looks like it's in agreement with that. Moist early on, but then drying as we get into tomorrow and going throughout the day tomorrow into Wednesday. And there's the European, again, 0Z tonight, lots of moisture, same trend, so we could all agree on that. This cold front is going to be passing through early this evening. Cloud cover I'm not going to spend that much time on, but you could see, you could definitely see the boundary of the cold front where you see the clouds going down in this kind of kind of linear array, I guess is the best way to say it. Again, this is the actually I could load up the new one because the new one's probably 12Z run's probably out. But here's the temperatures. And one thing I used to always do when I forecasted before I interned was I always used to just look at like regionalisms and just look at regions in the Animator. But actually, I found it works better to actually look at the whole country. So here's the temperatures at 0Z, and you can see it's relatively warm across the definitely very hot down in the southwestern U.S. across the desert. Looks like it was relatively warm today. Temperatures were about average or so for this time of year. And here's actually something that Bernie Rayno, shout out to Bernie Rayno, taught me my second week or so as an intern. So pretty much what it is we talked about CAPE and SYN just before, and you could have all the CAPE you want. Just because there's a lot of CAPE doesn't mean that there's a thunderstorm that's going to be happening. And this is what I'm talking about lift, like I said earlier. See, this is 0Z tonight, and as you see, we have a shortwave trough coming down from Canada, so these are vorticity maximums. And these vorticity maximums, these shortwaves, enhance lift. So, you know, that's really the thing that I guess I'll say pulls the trigger when you're forecasting for severe weather is there going to be lift? Let's update this because the 12Z runs out. Actually, let's going back to the SPC mesoanalysis. I remember I saw there was a K index on here somewhere. Right here. Okay. So K indexes of about, let's see, what does that say right there? It's kind of hard to read. But it looks like the K indexes are over 30, which definitely supports, you know, convective weather. Going back here, actually, we could talk about that right now because I brought them up on AccuWeather Pro right here. Yeah, so here's the K index for 0Z tonight. Very, very, very high. K indexes are over 30, according to most of these models except for the European. But GFS and the NAM are in agreement that the K index is going to be relatively high, so pretty supportive of convective weather. 0Z, the Euro, maybe the Euro might be a little faster. Okay, so this is 18Z this afternoon. The Euro shows, you know, K index is between 25 and 30, so still relatively, you know, good for convective weather. Moving back into the shoal water index, so we want negative values. The more negative is, the more you know, severe weather potential, more convective potential there is. Positive, less. So these are basically indexes showing measuring instabilities as well. It looks like we have shoal water index values at 0Z tonight between, you know, -1, 0, -1 to -2. So, you know, relatively pretty unstable. Going back to 18Z today, shoal water indices are higher. So definitely severe and convective weather are supported for the day today in the early part of the evening. So here's the lifted indices, and the European didn't really have an output for this, so it's just they just have the GFS, I mean, and the NAM, yeah. So this is 0Z tonight, the lifted index, and yeah, values are definitely, you know, same as kind of as the shoal water index. Values are between well, this one, the NAM has it even more so, between -3, -4, you know, up to -6, and then the GFS has you know, -2 to -3. So yeah, decent lifted indices. You want same kind of thing with the shoal water index. Where did I have the here it is, precipitable water. Okay, so at 0Z tonight, this is the NAM. Both 12Z, NAM, GFS, and ECMWF runs show a large plume of precipitable water, which is very good for you know, severe thunderstorm development in general. You could also see Blanca down here with this huge plume of precipitable water, and that's typical because it's a tropical system. It's a hurricane. So yeah, it's precipitable water values are between, usually in this orange color here, right around State College, you know, 1.6 and 1.8. You know, pockets of higher precipitable water over 2 inches. Which is what the NAM is showing over some areas of Pennsylvania and Tennessee. So very, very good areas of that the GFS and Euro is showing. A little bit more eastern Pennsylvania, and it's getting into Jersey and, you know, southeastern New York, between 1.8 and 2, so 2 inches. So again, precipitable water values are very high. Definitely parameters are looking good for severe weather. Let's look at the convective inhibition in CAPE, but we'll look at CAPE first. So 0Z tonight. One thing actually that I learned from Dan Kotlowski, who's a senior forecaster at AccuWeather, good thing I learned was that when you're forecasting severe weather, what I always used to do is to look at the bullseye. So I would say, for example, oh, look at this bullseye right over here in northern Arkansas of, 3 to 4,000 joules per kilogram of CAPE. That's actually not the best place to go to pick for severe weather. You actually want to pick it along the gradient of CAPE. So like gradients like here along the backside, there's a lot of times a good CAPE gradient along the dry line in western Texas to eastern New Mexico, western Kansas. So those are the those are the places that you really want to look. So here's the CAPE 0Z tonight. Values of really big pocket of CAPE over here in southern central Pennsylvania of 2 to 3,000 joules per kilogram. You usually want at least 500 to 1,000 joules per kilogram to support thunderstorms. The GFS showing, I guess, a little bit of a fast bias, and the Euro, shows CAPE values of, ranging from like 300 to 1,000 to 1,500 and a little bit eastward. So, actually, the Euro, this is wrong time. Sorry about that, folks. Some of the new model runs just came out, and I was looking at some of the older ones before, and then I didn't even notice the model run changed. Oh, sorry about that. So you look CAPE close to it. Sometimes it's kind of hard to find things in here. Here we go. Oh, here we go. CAPE. So let that load up real quick. That's why it was outputting a little bit differently, because it was a different model run. Let's see if the CAPE is gonna agree with the GFS. But in the meantime, we could, while we wait for that to load up, we'll talk about SIN, since SIN is very important with CAPE. And according to the NAM and the GFS, the European doesn't output SIN on here, but the NAM and the GFS are showing very little to negligible SIN, especially the NAM. So, that's good, because that'll also help parcels reach their LFCs, and it'll help support thunderstorm growth and development and convection. Now this loaded up, so we could take a look at this, and yeah, it shows values of it shows a little low for what the SPC mesoanalysis has, but values of 200 or so. So that's not the best, but then you have these pockets of these yellows and oranges, which are at least 500, which are good for severe weather development. So yeah, I'll show all the since this now loaded up, I think, because we had a problem with this before. It looks fine now, so we'll show the shortwave coming through, and yeah, you see all these little areas of vorticity evection, positive vorticity evection. So you have these short waves coming through from Canada, which are really enhancing the lifting in our atmosphere, which all the models look like. As you see, they're consistent in that, which is causing the lift to initiate these storms. And now I guess to look at some more short-term stuff. I opened the radar again here to see what kind of a handle because I have so many tabs open, what kind of a handle it has on the current regional situation. So this is the radar now at 2018Z and 20Z 18 minutes. So we'll see if the HER updated at all. I guess it did not, but anyway, this is the 19Z run of the HER. I guess we'll go on to 20Z because it's similar to the radar, not much different. And then here's the 4-kilometer high-res NAM at 20Z. And as you see, compared to the radar, this is the current radar. This is the 4-kilometer high-res NAM. Again, current radar, 3-kilometer HER. So the 3-kilometer HER has a much better handle on the situation than the 4-kilometer high-res NAM, which is usually the case I've seen throughout the course of the semester and the summer. So we'll look at both, but in the short term for this evening, let's look closer at the HER. So the HER shows, showers and thunderstorms, some severe lines moving to the east, and then some showers and thunderstorms ending out into the early morning hours around 9Z, which is when this run ends. And the 4 km HIRS NAM, I mean, again, take what the 4 km HIRS NAM says with a little bit more of a grain of salt, because it has less of a handle on the current situation, on the current radar situation. So again, the 4 km HIRS NAM shows lines of showers and thunderstorms, some severe passing through our region, and then getting into tomorrow morning, not so much in the way of interesting weather tomorrow, according to the 4 km HIRS NAM. Now let's look at some soundings real quick, I guess, to already, wrap things up. Here's the 18Z wrap sounding. So this was the current conditions of the upper air soundings at 18Z. And as you see, we have a lot of moisture towards the ground, low-level moisture between, let's see, 850 and about 725 millibars. You don't have much of a curvy hodograph. You don't have much of a vertical wind shear. However, the reason why I think the National Weather Service has issued tornado warnings and tornado watches for central Pennsylvania is because you see the winds have a good of horizontal shear. Because when you think about it, the winds here are slow. The winds here are much faster. So you have like a 10-knot wind and a 45-knot wind. And that will enhance, if you put a pinwheel there to represent it visually for you, the pinwheel is going to spin this way, because spin clockwise, because you have much faster winds here than here. So the faster winds aloft will make a lot of horizontal vorticity, a lot of horizontal shear. Now this horizontal shear, because in central Pennsylvania, areas like this, we have terrain, we have mountains. It's not like Long Island, in New York City, where it's like just flat and just some small hills. The difference in Pennsylvania is we have better chance for tornadoes here is because the mountains and the upslope will essentially convert or kind of tilt the horizontal shear right here into vertical wind shear, and then that vertical shear will have vertical vorticity. Mean vertical vorticity. So that definitely is good for tornado development. I guess now looking, see, this is 18Z. So looking 6 hours ahead to 0Z tonight, get an idea of what the sounding looks like from the wrap. Oh, these soundings are all over State College, Pennsylvania. It looks like, according to the wrap at 0Z, conditions look a bit more stable. Let's see, if we take this, follow that line, that still some decent cape. And then this is the 12Z NAM sounding. So let's go 6 hours ahead to 18Z today and see what the NAM has. The GFS I'm going to spend really quick on, because the GFS isn't that good at picking up mesoscale features as much in the soundings, and they have I noticed they have a bias where they think that they have a very large moisture bias. So I noticed the GFS really overestimates the moisture aloft as well. So the sounding shows good instabilities, but except for this one little area here, this one little looks like more of a stabler layer. But nevertheless, still looks pretty good. Oh, wrong window. And the GFS, let's load that up to 18Z today. Although does GFS have it over State College? Because sometimes the GFS messes it up. Yeah, the GFS messed it up. But it's still central Pennsylvania. This is that moisture bias I'm talking about. It really overshoots the moisture, but still looks like a decent profile, especially with the shear. Looks like we kind of have a little bit of a low-level jet around here. Actually, yeah, let's take a look at that. I didn't open that up, but that's another good thing we could look at. I could talk about some things in the meantime while it loads up here. So let's see, where is it? It's kind of hard to find it, because this is something I haven't really looked at that much until I started interning this summer. So another shout out to a new thing I've learned. Sometimes it's not about how good of a forecaster you are, it's about the learning, and that's really the truth. Okay, so here's the low-level jet. Let's go to the NAM, and then let's see if the GFS and Euro have it too. Yep, they do. And okay, yeah, just the GFS and the NAM have it. The Euro, I don't want to look at low-level cloud cover. So I guess going back to, let's go back to the SPC meso analysis, just because they have good representations of a lot of things. We could look at at the lapse rates, because lapse rates are also instability parameters. And actually, one thing we could look at is see if there's what the mid-level lapse rates are. They're not that much, so I don't really see. They're not that high, so I don't really see. And in the soundings, I don't really see, elevated convection. Although elevated convection is more common across the plains than the eastern United States, because the plains you could have that really, that wind shear, that clockwise. Hodograph, that clockwise vertical wind shear. So at the surface you're having winds out of the southeast or the east southeast, from the Gulf, bringing in moisture at the low levels, turning clockwise with height, and then mid levels you're having winds coming from over the desert southwest, which makes the dew points really drop off. So the sounding would look more like the dew points would be more like dropping off towards the mid-levels, which will also enhance elevated convection, because then that will increase the lapse rates, aloft, and that's very good for supercell and thunderstorm development, which is why the plains is one of the, in the United States, which is why the plains is one of the best areas to find severe weather. So let's see quickly if the lower level jet, oh yes it did, and yes, good diagnosis right there. The low-level jet looks like it's enhanced around this region. You really see it along the northeast United States. This is at 0Z tonight, both 12Z NAM and 12Z GFS runs. So I was right in the sounding right there, because you saw, I'll show you with the wind barbs again. But this is the GFS sounding. The winds are about, 25, 30 knots towards the surface. Well, surface like 5 knots, but, lower levels 25, 30 knots. And then above, the winds are slower, 40 knots, but then you have this pocket between 500 and about 600 millibars of 50 knot winds. So, and again, the NAM shows it well, and the RAP shows it. So again, a good diagnosis right there. The low level jet, and the low level jet's actually very good to help develop thunderstorms and severe weather. We all learned in our meteorology classes. So again, my outlook looks like chances for showers and storms are very likely in the earlier part of the night, depending on where you are. Storms are moving from northwest to southeast. So Long Island, New York City, folks back at home, you're gonna get all these storms a little bit later than what I said for Pennsylvania. Probably more towards taking a look again at the HER, because the HER had a decent handle on the situation, just to get a rough idea. Probably more towards around 3 to 4 Z, so that would be about around midnight later in the day. So definitely don't plan any outdoor activities tonight, because it's not looking good. And just, I guess, keep updated on the current severe weather situation. I guess we could take a quick look backtrack here and look at the warnings over a larger area, see what the National Weather Service has issued. So the National Weather Service has issued severe thunderstorm watches throughout the more south and west, tornado watches, surprisingly, in the northeast, with also flood watches, typical of severe weather. And then tomorrow, when we look at our temperatures, and actually I'll bring up the dew points too, to give you an idea of what the humidity is going to be like, since the cold front's passing through this evening and tonight. So temperatures at 18Z today were about, in the, like I said, low to mid 80s for most of the region. And then 18Z tomorrow, temperatures generally look like the models are trending cooler. So like maybe more like mid 70s. And I guess just to get an idea quick of what the humidity is going to be like, we'll call up the dew points right here to see if we're going to have some drier air intruding as this cold front passes, which I generally think is going to be the case, because when you have a continental polar air mass replacing a maritime tropical air mass, you're going to have the dew points drop off a bit, and things are going to be a lot more comfortable with lower dew points. That's why part of the reason is they say they say down in Arizona and the Southwest, it's despite temperatures are, again, let's see what they were in the Southwest. Well, again, another idea is look how low precipitable water is not usually that high across a lot of the Southwest, southern Arizona, but that's just because of Blanca right here. But if you look more towards areas where you have these purples and dark blues, that's more typical across the desert Southwest. It's usually very dry, arid, air. But yeah, temperatures like they were showing were more in like the 0Z tonight. More like around 100 degrees, but it's a dry heat. You don't have all the, like you see the dew points. You have this big area of lower dew points, and that makes it a dry heat. So it's actually kind of more pleasant than it is, for we're having in the Northeast United States right now. So yeah, this is dew points at 0Z tonight. Upper 60s according to the 12Z runs of the GFS, NAM, and European. But then we'll go fast forward ahead to I guess 18Z tomorrow, and definitely looks drier. More so upper 50s to lower 60s, and then going into Wednesday, definitely again even more dry. So that definitely agrees to what the concept is of cold fronts. So again, be careful, be safe, be smart. This is student meteorologist Eric Drewitz with Weather International, also forecast intern at AccuWeather. Please follow Weather International for your latest forecast updates and discussions and weather updates. Definitely trying to promote weather awareness with these severe weather outbreaks this summer. And this is again student meteorologist Eric Drewitz signing off. Enjoy your evening and enjoy your week and enjoy your day.